Welcome back, guys. My name is DrAvitech, and in this video we're going to be talking about, or we're going to be solving questions for JAMB 2026. If you are new to this channel, you could check out the former playlist where I solved over 200 questions for JAMB Mathematics 2026. So today we're going to start physics, and I don't know, I might make this very video longer. So instead of breaking it into 40 questions, I can just do a straight video solving more than 40 questions. So what you have to do is, if the video is very long, you could pause it, take a break, and then you come back. Now remember, for every question here, try to solve it so you understand what's going on, and then you check your answer with my solution to see if the answer will be the same. Now remember, if you want to be that student who scores very high in physics, you need to complete this very video. And of course, if you're a math student, go check out my maths playlist. So without further ado, let's get started. Meanwhile, hit the subscribe button, like this video, and share it across to everyone. So the first one says, an axe head of 27% efficiency. So I would like to write that as 0.27. So 27% efficiency means 27 divided by 100. Now, was used to cut down a tree. If its length and thickness was 150 and 25 respectively. Now, what is the velocity ratio? Velocity ratio in this case will become that length divided by the thickness. So this will become 150 cm divided by 25 cm. So this will give us 6. So that's our velocity ratio. We're asked to find a mechanical advantage. First, remember that efficiency is mechanical advantage divided by velocity ratio times 100%. Oh, I've not covered this though. To prevent that weird sound. Yeah. Okay. So sorry about that. So that's 100%. Now, the efficiency is 0.27. So this will be 0.27 equal mechanical advantage over velocity ratio is 6. Since I've divided this by 100, there's no need for me to put this 100 anymore. Now, I could say over 1 here, then I cross multiply this with times this. So I would then be having 1 times MA is MA, then equal 0.27 times 6. So when you multiply this, what would we get? You get 1.62. So the answer to this question becomes B. So that's what you're going to get. Let's move on to the next one. Number 2. What's number 2 about? Calculate the length of the liquid columns in a barometer tube if the atmospheric pressure is this. So our pressure is 4.8 times 10 to the power of 4 Newton per meter squared. And then the liquid has that density. So density, which is rho, is 800 kilogram per meter cubed. It's used in the barometer. Then we're given a solution due to gravity as 10 meter per second squared. So to start with, pressure is going to become the density, or let me start from the height, or length rather. Let me call it height times the density times gravity. Now we're looking for the height, so I could divide both sides by rho g. So this becomes P over rho g equal to the height. So this means I'm going to run my pressure first. So that's 4.8 times 10 to the power of 4 divided by rho is this. So that will be 800 times the gravity is going to be 10. Now, this is 4.8 times 10. This power of 4 means I'm going to be having 4 zeros here. So that's 10,000 divided by 800 times 10. 0 we cancel 0. 0 we take care of 0. 0 we take care of what? 0. So 4.8 times 10 is actually 48 over 8. So 48 over 8 will give us 6. So the answer is A, 6 meters. So that will be the answer. Let's move on to number 3. Now, if you're taking JAMB Physics, take note that most of the equations are going to be theory based, unless you are not very lucky. That's when you're going to have calculation, lots of it. But the exam is structured in such a way that if you're someone doing maths, you'll most likely be doing lesser calculations in physics. But sometimes it's not true. All right. So what we're going to do is a uniform bar AB. So this is the bar A to B. It's of length 5 cm. And it has a mass of 6 kilogram. It is balanced as shown in the diagram above. So a weight of 100 Newton is applied at the point P such that BP is 2 meters. Should I be meters? I think I should call that meters. Everything is in meters. Why is here cm? Okay, it's 2 meters. Calculate the reaction at the point P. Now this is moment. This is moment. So it's going to be the sum of all clockwise movements equal to the sum of all anti-clockwise moments. Why did I call that movement? It's moment. So let's get started. If you look at this, this is where the point, this is the point we have P. And there are kind of like two reactions here. So we have the 100 and we have the 60. So we're going to find the moment at this point. Remember, we're going to be doing the force times the distance. So for this first one, if you look at this, from this point here, we're going to have this is just 1 meter away. So we're going to be having 60. Where is that? Yep. 1 meter. And then let's take our 60 first. At this very point here, we're going to be having 60 times 2. Because the distance from A, the distance from A to this very reaction is 2 meters. So the moment at this point is 60 times 2. And then plus, the next one we have is 100. From A, the distance is 3 meters from A before you get to 100. So that's 3. So this will be 3 times 100. Or you could say 100 times 3. So we've done this movement at this point, or this moment at that point. So the next moment will become this one. So this will be equal to, let me call that RP. So, okay. Let me call that RP. I think that makes, did I call it RP here? Anyways, let's call it RP. Okay. So we're asked to find the reaction at the point P. So RP, oh God. I can call it that. So this will become, the reaction at this case is, it's like finding the reaction at this very point here. Because it says that such that BP is this. So to calculate the reaction at this point, we need to find what's going on here. So the distance, the total distance here is 5. So this will be 5. So this is the reaction times 5. That's what we're going to be getting. So 6 times 20 is 120. And then 3 times 100 is 300, equal to 5 RB. Okay. Yep. I think that's better. Reaction at B. I think that's better. Is this, wait, are you sure there's no reaction at the point B? God, I'm copying. Okay. So that's RB. Now this plus this will give us 420 equal to 5 RB. It should be reaction at the point B, not P. Anyways, I'll check that later on. Divided by 5 divided by 5. So RB would then become 84. So this will be 84 Newton. So this will become the answer to that very equation. Let's move on to the next one. A gas cooled at a constant pressure from 57 degrees Celsius was observed to shrink 1/5 of its original volume of this amount. You have to find the new temperature. Now, if the pressure is constant and we're having temperature and we're having what? Volume. So question 4. Remember from gas laws that V and T would become V1 T1 equal V2 T2. I don't know if you recall something like this. Okay, so this is the formula we're going to be using. But then This very guy must be in Kelvin. So our temperature, our first temperature has to be 57 plus 273. So that will give 330. I don't want to make any calculation errors. So that would be 330. So this would be 330K. Now, we're told that it was observed to shrink 1/5 of its original value of this amount. Now, I don't want to use this, it's going to be a stress. What I'm trying to say is, if my V1 is 1, then V2 is 1/5 of that very thing. So I don't really need to stress myself. So I'm going to put 1 here over 330K equal V2, I'm going to put 1/5 over T2, which I'm looking for. Now I could cross multiply. 1 times T2 is T2, then 330 times 1/5 will become 1/5 times 330, which basically means you are dividing by 5. So this should give 66 Kelvin. That's what we're going to be getting. But then the option is in Celsius. So to get Celsius, we're going to subtract 273. So this will become 66 minus 273. So when you subtract that, you get minus 207 degrees Celsius. So the answer for that one, the answer for this one is A. The answer for this one is D, minus 207. All right, number 5. Now, there's no calculation there at number 5. So here's the thing. Why is it that the bottle of Coke from the refrigerator or from the freezer is suddenly covered by moisture? Now you bring out something and then it's now looking as if the water is sweating. All right. Now, this is because the air around the bottle has cooled down beyond its dew point. That's it. It has no connection to freezer. It's too cold. The freezer is supposed to be cold. That's why we won't put the Coke inside. So that's it. That will be the answer to that one. Number 6. What difference in temperature can make a metallic meter rule expand by 0.2 centimeters? The coefficient of linear expansion is 12 times 10 to the power of minus 6. So for this one, number 6, you need to remember that in linear expansivity is the change in length per unit degree rise in temperature. That's the formula for linear expansivity. Now we're asked to find the difference in the temperature. So we're asked to kind of make this the subject of the formula. So let's first of all times. You know I can put over 1 year and then times. 1 times change in length will become change in length equal alpha L1 change in temperature. So to get my change in temperature, I have to divide by alpha L1. So or alpha L1, alpha L1. So when this cancels this out, I have my change in temperature equal to change in length divided by alpha L1. So what is my change in length? It expands by this, so this is the change. So that would be 0.2 divided by, what's this? This is 12 times 10 to the power of minus 6. God, hold on. Minus 6. And then times L1. Hold on. Let me see. Okay, so a meter rule on its own, an important information, sorry. Now, a meter rule, we know a meter rule is a 100 cm, ideally, it's 100 cm. It's 100 centimeter, that is what it is. So, if we have our change here, we have to convert this to its respective units. Yep, we have to convert this. But I don't think I should be doing that. It's not supposed to change anything. Since they're both in cm, I'm going to use 100 cm here. Equal to change in temperature. So when we do this, you should get 166.7 degrees Celsius equal to change in temperature. Please take note. In this case, I did not convert. Take note, there are times where you have to convert. You see that if I should put my cm here, with the 0.2 cm, and then this 100 and I put my cm, they'll both cancel out. So that's why I did not really stress myself about that. But it's very important. It's very, very important that you convert. But since I'm already using 0.2, I don't have the strength to be converting again. So that should be the answer. You can check with your calculator. Now for number 7. So this is a block of glass. Light, let me see, they use light. Okay, but light is coming from air, goes into the glass and then comes out. So they're saying that if SQ is 10, so this is SQ, this is 10, then SR is 6, so this is SR is 6, so this would be 10, 6. What's the refractive index? So what's that symbol again? So refractive index is always incident, let me just put incident, sine of incidence over sine of R. That's what it is. And in this case, it would simplify to, let me see, 10 over 6. 10 over 6. So our incident guy will become this length here, so that will be 10 over 6. When you simplify, you get 5 over 3. So this is 1.667. 1.7. So that's what we're going to be having. So this is the simplest way to just do that very equation. Number 8, I think I'm going to wipe the board at this point. Okay, so let's continue with number 8. A boat at anchor is rocked by waves whose crests are 120 cm apart and velocity is this. At what interval does the wave crest reach the boat? So to start with, solution. Now for question 8, you need to remember that velocity is equal F lambda. Velocity is F lambda. And then F is actually 1 over time. So that will be velocity over time when you then put the F. F is 1 over t. Now we're asked to find t. So this basically means I can make t the subject. If I flip this 2, this means that t is equal lambda over v. And here's the thing. If the crests are 1, so that's one wavelength. 2 successive crests, when they are 120 cm apart, that means lambda, the wavelength, is 120. Over velocity is 30. When you cancel this out, you get 4 seconds. So the answer is equal to D. Next one, violet is most deviated in a color spectrum. It implies that it has a lowest wavelength of the white light, lowest frequency, and the highest wavelength. Now, it's most deviated because it has the lowest wavelength and highest frequency. So it's either you see lowest wavelength or the option can be changed and you have highest frequency. Not lowest frequency, highest frequency. So it happens at lowest frequency because lowest frequency and highest frequency. That's why it happens. The next one, a body stands in front of a tall wall and produces a sound. If he receives the echo of the sound 3 seconds later, his distance from the wall is dash. To start with, you need to remember that the distance you take for you to hear your sound. Let me use this part to explain. I don't want to. So let me say this is me, for example. And then this is a wall. A thick wall. Now when I talk, when it gets to this wall, let me say the distance is D. If it's coming back, it's going to be another D. So that's like 2 distance. I wanted to say 2 distances. So that will be 2D. Is that okay? Now, for number 9, this means 2D is equal V times T. That's it. The distance, V, is going to become 2D, so that's V times T. So we're looking for distance, so this will be 2D equal, velocity is 330 times the time. This will be a decimal. Oh, it isn't. Okay. Times T is 3 seconds. So that means D will become 330 times 3 divided by 2. 330 times 3 is 990. Divided by 2 is 495. So this will become the answer to question number 9. Next one, question. Hold on. I've already answered number 9, so this is number 10. Then number 11, a body stands in front of a tall wall. God, I've already done that. A boat or an airplane has a pointed front or head. This is to A, look good. Of course, now for beauty. Okay, now the number 11, the reason we have number 11 is this. First of all, there's a drag. Let me use airplane for example. Imagine if the front of an airplane is just like this. You know that an airplane is actually countering air pressure. Because just imagine if you want to pierce through something. Okay, people that give injection. Let me use that a weird example though. When you inject someone, you notice that the needle is actually having a pointed tip. This is to make sure that it reduces how much drag, like the force of the surface from the needle. So when it comes to an airplane, let me use an airplane. It pierces through the air with that very point. So the reason it's that pointed is so that it can reduce how much drag we have. And in that case, drag is friction. Now, they only said fluid. Yeah, I think they were just using the boat. So I'm using the airplane to explain. But for a boat, of course, you're going to reduce the friction when you are at sea, the friction of the fluid. So the answer is what? The answer is B. Or you could say it reduces drag. So take note, that's why we have this very guy. Okay, the next one, question 12. The turns ratio of a transformer is which supplies a voltage of this in the secondary from a primary voltage of this is dash. You need the turns ratio. So TS, okay, let me say turns, T arrow, turns ratio is VS over VP or NS over NP. So our VS, which is voltage in the secondary, is 300. Voltage in the primary is 600. 3 over 6 will give us 0.5. So the answer is D, 0.5. That's the turns ratio. Take note of transformer. Take note of transformer. Number 12. What is the mass of a photon of wavelength this which behaves like a particle? So we have the constant Planck, and then we have C, which is speed. So to find the mass, M is equal H over lambda C. Thank God I've already written this. I don't have to always go and calculate the value and waste time. So the mass is going to become our Planck's constant divided by lambda C. So this formula stays constant. It's from the Broglie relationship. So our H is 6.63 times 10 to the minus 34 divided by lambda. Yeah, that's the wavelength. 7 times 10 to the minus 7. And then the speed 3.0 times 10 to the power of 8. All right. Now, if you calculate this, let me see. This should be minus 7. So minus 7 and 8 will give us 1. So 1 goes up minus 35. This is 21. I don't want to use a calculator for this because it's going to take my time. But the answer, when you calculate this, the answer should be this. It should be B. That's what the answer should become. The answer should be B. 3.2 times 10 to the minus 36 kilogram. That's what the answer is going to be. All right, question 14. Question 14 is actually a very big problem. I don't know why this question was set like this. So you could let me know what you think in the comment section. So we need a method of demagnetization, not magnetization. Now looking at all of these options, I would like to pick B as the best that suits this. I would like to pick it. Now D would have also been the best, but here is why I might not. It's between B and D. Take note that C, when you double stroke, you are basically magnetizing, not demagnetizing. So this part of heating a magnetic bar red hot, of course, when you heat it up, you're basically demagnetizing it. But it does not say to what degree you have to heat it. If you're heating it to red hot, you might actually demagnetize it. But then, there's a point where you will get to and it will lose all magnetism. So the answer is between B and D. But I would actually pick B as an answer because you are placing it in a solenoid. So that's using the alternating currents to demagnetize it. So I'm going to pick B. But the answer is between B and D. I'll just pick B. All right. So number 15 says 113 electric heater turns 0.02 kilogram water at 100 degrees Celsius to steam at the same temperature. You have to find how long the process took. To start with, anytime it does not involve change in temperature, it has to deal with a latent heat. It has to deal with latent heat. And in this case, since we're talking about electric, remember that, question 13, the quantity is always ml. Quantity is always ml. But in this case, the quantity of the heat, since we have an electric heater, the power times the time will give us ml. So we're looking for time. So time will become ml over the power. So m is 0.02 times the latent heat of fusion, to steam. So that's vaporization. Turns this to steam. I think this should be LV. LV, not LF. Sorry, this should be LV, vaporization. So that's 2.26 times 10 to the power of 6 divided by the power is 113. Now, if you do this correctly, because it's calculated, this top will give you 45,200 divided by this. So this should give you 400 seconds at the end of the day. So that's C. All right, the next one, what number is it? That should be number 16. So number 16. If the length of a simple pendulum is 120 cm, so let's convert this first. This will be 1.2 meters. Calculate its frequency. To start with, let's find the period. Let us find the period. Remember that T is equal 2 pi with the square root of L over G. Remember that that's the formula for period. So this will be 2 times 22 over 7 with the square of the length is 1.2 divided by 10. So this will be 2, I think I've already calculated this. This should be 2.17 seconds at the end of the day. That's what it should be. So our frequency is 1 over period. So this will be 1 over 2.17. So this is 0.5 hertz, approximately 0.5 hertz. So that's what we're going to have. Question 17. Calculate the depth of a swimming pool if the apparent depth is 10 centimeter. Refractive index of water is 1.13. So refractive index is 1.13. And then we know that the apparent depth is this very value. Now refractive index is always real over apparent. It's over apparent. I think I would like to call that fake. Apparent should mean fake. So that's it. So this means 1.13. This is a bracket, please. This is a bracket. So 1.33 is equal real over our apparent guy is 10. So this means the real guy will become 1.13 times 10, because when you put over 1 here, you can then multiply. So when you multiply, this will give you 1.33 times 10. So that will be 13.3 cm. So the answer is B. All right. So let's continue solving. Let's move on to the next one. All right. So question 18. The total energy required to move a positive charge around a complete electric circuit is the electromotive force, EMF. That's the total energy to move a charge around the circuit. All right. So the next one says, what is the power of a 50 kg young man? Did you really write 50 kg there? A 50 kg young man who climbs a 25-meter tree in 5 minutes. Okay. First of all, we need to agree that question 19. The energy of the work done in this case will be mgh. The mass times gravity times the height. Yep. So the mass is 50 kg. G is 10. Then the height that was climbed is 25. So this should be around 1 to 500. So this is the energy. But then to get power, we need to do the energy or the work done divided by time. So this will be 1 to 500 divided by, it says 5 minutes. So let's convert 5 minutes to seconds. We need to times by 60. Yep, we need to times by 60. So when you divide this, you're going to have approximately 42 watts. So that will be the answer. That will be A. The next one says, water waves and light waves differ generally in their medium of propagation. That will be the answer to that very question. One of the following is an optical instrument which has an objective made of convex lens and an eyepiece made of concave lens. Why can't I even see this question? All right, the answer to this is going to be A. That's Galileo telescope. That will be the answer to that very question. Now, question 22. We're asked to find the coefficient of friction in the diagram above. So for this one, 22. So question 22, well, to find the coefficient of friction in this very equation. And for this one, first, the mass here is 1 kg. So this means that the weight will become mg. So this will become 1 kg times 10. So that will be 10 Newton. So that's the weight of the block. That's what the weight is pulling down. Now, to get the normal reaction, R, to get the normal reaction, it's always the weight minus the upward force. Upward force. So our weight in this case is 10 Newton. The upward force is 5 Newton. So this will then give us 5 Newton. So that's our reaction. The mu, which is the coefficient of friction, is the frictional force. I cannot spell frictional again. Frictional force divided by the normal reaction. So our frictional force in this case, we could see that that's 5 Newton. So that's 5 Newton divided by our normal reaction is still 5 Newton. But 5 over 5 will give us 1. Now that in itself is a problem because apart from the fact that 1 Newton is not in the option, it is almost impossible to get our coefficient of friction as a number greater than 1 or as a number that gets up to 1. It's always in the 0 point something. So this very guy here should not be 1. So, and in fact, there's no 1 in the option. So the only assumption here is that they avoided the upward pulling force. So that is to say, they didn't use the upward pulling force. So this part was just taken away. And then the normal reaction was left as 10. So when you leave that as 10, this means this will become 0.5. That's the only explanation for this. However, if you think something else, you can let me know in the comment section. Question 23. Now this one is a basic, it's more like a basic thing if you play with electronics. When you connect cells in parallel, you're basically keeping the voltage the same, keeping them the same, and then you are increasing the current. So in this case, the overall or the total EMF at the end of the day is actually still the same with each of these because these guys are what? Parallel. So when you connect in parallel, the voltage stays the same, current increases. But what if they were asking for the total current? Total current I will become I1 plus I2 plus I3. because the current will increase and the voltage will stay the same. So in this case, the answer for this one is going to be A, because our EMF will stay the same. Question 24. Okay, so no need to even write 23. Let me just go to 24. What is the work function of an unknown metal having a threshold frequency of this, and then we have this guy and this guy? So to start with, our work function let me call that phi, is equal HF. So H is 6.6 times 10 to negative 34. Then times F is going to be 3.9 times 10 to the power of 14. I've calculated that, so I don't want to stress myself. So this will give us 2.574 times 10 to the power of minus 19 joules. So that's what we're going to be getting. It's a work, so it's in joules. But then if you notice, the options are in electron volts. So how do we convert this? To change this to EV, you need to know that this will become the work that I've just done divided by E. That's a charge. So this means we're going to be having 2574 times 10 to negative 19 joule divided by 1.6 times 10 to the negative 19 C. Now when you do this, you should get 1.61 electron volts. So that will be the answer. Yep, this will be the answer. Okay, question 25. Question 25. So an electron with speed 4.5 times 10 that would have a wavelength of this. Now this very question, it seems as if the correct option is not there. So let's put this into play. To start with, we have speed, so that's our V. So V is given, for us to find wavelength. So wavelength is equal H over mv. It's equal H over mv. So that's what we have. So this will become, we're not even given, why are we not given the Planck's constant? Unless they assume we should know. So this will be 6.6 times 10 to negative 34 divided by m, which is the mass. It's an electron. So that's 1.6 times 10 to the negative 19. We should know that that's so H is 6.6 times 10 to negative 34 divided by mass. It's an electron, so the mass of an electron is 9.1 times 10 to negative 31. The velocity is 4.5 times 10 to the power of 8. Okay. So the answer for this, I think I need a calculator because the answer was not the same. I had to just leave it. So hold on. All right. So if you divide this, you should be getting 1.616 times 10 to the negative 12 meters. That's what you'll be getting. Now, it says we should change it to millimeters. So this will be 1.616 times 10. Now, I can split this minus 12 to minus 9 times 10 to the minus 3 meters. So this will become 1.616 times 10 to the minus 9. Now, this very value here, 10 to the minus 3, would then become millimeter. And as you can see, none of the options fits that. That's the problem. That was what I got. None of the options would fit it. So let's just move on. No option fits it. Okay, it seems there's still a bit of space, so I could do question 26 here. Could do question 26. So question 26. So question 26 says 1 kilowatt of electrical energy consumed is equal to dash. So we have 1 kilowatt hour. So to start with, a kilo is 1,000. So this is like 1,000 watt hour. All right. So this is 1,000 times an hour. First of all, we need to convert to seconds. So let's start from minutes. There are 60 minutes in an hour, and then there are 60 seconds in 1 minute. So that's 60 times 60. And then we're going to then have watt S. WS, that's what we're going to be having. So this will then become 6 times 6 is 36, so this will be 3, 6. And then how many zeros do we have here? Let me just put them. 1, 2, 3, then 1, 2. And then take note that, let's see, this will then be in joule. Let me see. Yep, that would then be in joule, because watt in itself is joule per second. So S, we cancel out S, so that will be in joule. Now we could write this in standard form: 1, 2, 3, 4, 5, 6. So that's 3.6 times 10 to the power of 6 joule. So the answer for that will become C. Now let's move on to the next one. All right, so we have question 27. The incident ray with angle of incidence 30 degrees on a plane mirror is deviated by dash. First, the deviation, the angle of deviation, is 180 degrees minus 2 angle of incidence. That's the formula for that. So this will be 180 degrees. Take away 2 into 30 degrees, because we're told that's the angle of incidence. So this will become 180 minus 60 degrees. So that's 120 degrees. So that will be the angle of deviation. Next, photovoltaic energy is the conversion of sunlight to electricity. No, your waste time. That one I heard the answer, because to start with, photovoltaic, photo means light, so that's solar panels. So that's saying your solar panel converts sun to electricity. That's it. Let's just move on. Now 29, I kind of feel 29 did not have so much, there's no much information, because how would I know in my head? You're going to see something very soon. So in a series, copper and voltage voltmeter, 10 gram of, there should be a comma here, 10 gram of copper was deposited. The mass of silver deposited is dash. To start with, this will be Faraday's second law of electrolysis. The first law is talking about 28. So for the first law, we have M equal ZIT. I don't know if you recall. Now, for the second law, it's talking about the ratio of the mass and that of the what? Electrochemical equivalent. So in this case, we're going to be having M1 over M2 equals Z1. You can call it Z1 over Z2. So that's the relationship. It says that when this mass, how do I put it? When it's just trying to say that mass and ECE, they are equivalent. So the ratio is a constant. So in this case, our mass, let me call this, we have silver and copper. So let me call the one silver, or let me call it copper, since I've already used this. Then silver will be AG and AG. AG baby. All right, so MC is 10, divided by the mass of silver equal ZC. Now, this is why I said we're not given enough information. So, but in this case, our ZC for copper, we're going to be using 31.5. And then silver is 108. No, we're supposed to be giving, though. We're supposed to be giving these very values, but we're not. So remember from chemistry that silver is 108 and then copper is 31.5 approximately. So this means to make the mass of silver the subject, we have to say 10 times 108, 10 times 108 divided by 31.5. So when you do that, you get 34.28 grams. That's what you're going to be getting for that very value. Number 29. So the answer for 28 is A. Next one, question 30. Hold on. 29. I've already answered 20. This numbering keeps on confusing me. This is question 30, please. And this should be 29. So question 30 says, one of these is a fundamental quantity. You don't need waste time. The answer for this one is D. Because the first topic in physics is fundamental and derived quantities. And this luminous intensity is there. It's stated that this is what? This is a fundamental quantity. The rest of them depend on other quantities for their definition. But fundamental quantities do not depend. They can stand alone. So that's for that very one. Number 31. A substance held with hand was placed in contact with the brass cap of an electroscope whose gold field was already diverged. So already the gold field in that very electroscope was already diverged. If the gold field remains diverged, that is, after bringing that very substance close to it, it was diverged before, they still brought it, it's still the same, it's still diverging. It's not converging, or it's not changing, it's just the same. What does this say about the object, or what does this say about the substance? It says that that substance is an insulator. That very thing is an insulator, because an insulator does not change the position of that very gold leaf. It's an insulator, a very good one at that. So that would be the answer to that very one. A conductor would actually change that very thing. But so whether it's conductor, either good, partial, or not, it has to be an insulator. Question 32. The gravitational force between two masses P and Q is 10 Newton. So already we have the two masses P and Q and it's 10 Newton. Good. Now what will be the new value of the force if the masses are doubled? But first, let's remember that this will then become 32. F is equal gm1 m2 over r squared. Now already, this value is actually 10 Newton. Now imagine if this our m now, this our m is now 2 times itself. So remember, anything you do here, when you do 2 times m1, also do the same thing here, 2. Because anything you do to one side, do to the other side. Then this m2 was also doubled again. So that's 2m2. So there's another 2 in front. So altogether, 2 times 2 is 4. 4 times 10 is 40 Newton. So the answer is going to be 40 Newton. And this basically makes sense, because your force from this relationship, force is directly proportional to what? To the masses. So if the mass is being multiplied by a number, that force is also multiplied by the same number. That's what it's basically saying. So if you look at this, if our number, the first mass was doubled, second mass was still doubled. When you double twice, that's 4. So it means your force has to be times by 4. So that's 40 Newton. Let's go to the next one, number 33. So this number 33 says the diagram above, the batteries are all 2 volts. Calculate the lost voltage of the circuit if the batteries have an internal resistance. To start with, if you look at this expression, we have 2 volts. But it's possible that not be the 2 volts they come aside, because it has its own internal, inside it has its own internal resistance. So first of all, the lost voltage will be, we'll call it small letter v, it's going to become E minus IR. That's the lost voltage, E minus IR. So our E is 2 volts minus, we have I as 0.95 times R is 2. R is 2. So this will become, oh gosh, hold on. I just want to get the answer straight. 0.1 volts. So that would be the answer. That would be the lost voltage, 0.1 volts. That would be the lost voltage. Okay, number 34. 34 says, what is the mass of a 4.5 times 10 to the power of minus 9 coulomb charged particle moving in a circle of this radius at a speed of this in the vicinity of a 140 micro Tesla magnetic field? That's weird. Okay, first of all, let's start by, we have to convert this. So R will then become, to cm, it means we're going to be saying this is 20.5 times 10 to the power of minus 2 meters. And then our Q is this value. So Q is equal 4.5 times 10 to minus 19 or minus 9c. Then speed V is equal 4 times 10 to the 7 ms minus 1. And then we have this value. Now take note that this value that you see here, we call it B. We call it B. So B is equal 140. But this thing you see here is 10 to the power of minus 6 Tesla. That's what we're going to be having. So to get the mass, M will then become, did I put all of this? Okay, so M will then become BQ R over V. That should be right. BQ R over V. So that will be the formula to get our mass. So our B is 140 times 10 to the minus 6. Our Q is 4.5 times 10 to the minus 9. Then R, there's no space. Okay, R will become 20.5 times 10 to the minus 2 divided by V is 4 times 10 to the 7. Now, if you do everything right in your calculator, you get 3.22 times 10 to the minus 21 kilogram. So that's 3.22 times 10. Yep. So the answer is going to be B. That's it. The next one says the thermal capacity of a body depends on one of the following. So remember that thermal capacity is the amount of heat required to move a body to a temperature of 1 Kelvin. So it's going to depend on the mass of that body and the nature of that very body, not the temperature. So this temperature and mass, nope. So it's going to be on the nature of that very body. So it's going to be C. It's going to depend on the body. All right. The next one, question 36. Now, if you look at 36, it says that in a diagram, X, Y, Z are vectors. Which of the following options give the correct relationship between the vectors? To start with, if you look at this properly, let me kind of draw this again. So we have something like, anyways, it's still the same. So this is, it's not the same one. Hold on. All right, so, let me see. So it looks like this. All right. So this is my X, this is my Y, this is my Z. Now let's say for some example, we're not considering X. Let's say I take out this X. What does this thing look like? You can see that Y is going to this point and then combines again with Z to go this point. That's what you notice, right? So Y is going from this point and then it combines with Z to go this way. Now, if you look at these two, it's like they're going in opposite directions. Now, remember that for these guys, this will be Y plus Z. That's what it's going to be. And then we have our X. So you see that this very X is actually going to become the sum of these two things. So the answer is going to become B. So that's what it's going to be. Now let's move to the next one, question number 37. Question 37 says a violin of length 120 cm and frequency of 400 Hz was set into vibration. You have to find the velocity of the frequency in the string. So to start with, 37, the length here is 120 cm. So this is 1.2 meters when you convert to cm. Where's that one? Now, we know that frequency is likely velocity over a length. It's likely velocity over L. So velocity over L. But then, this length, when you set a violin to vibration, the length here will be 2L. So take note of that. So velocity is what we're looking for. So you could say to make V the subject, put over 1 here, 1 times V is V, then F times L will give us 2FL. So that would be 2 times 400 Hertz times the length is 1.2. So this is 8. This will be 8, 4. Hold on. 2 times is 8. 8 here. Oh, don't worry, I've written the answer before. So let me just look for it. 960. Sorry. 960. All right, so that's what we have. The next one is number 38. So 38 says in the above circuit, what is the impedance? First of all, impedance is Z and is the square root of R squared plus XC squared. Because in this case, we only have capacitor. So to find XC, XC is 1 over 2 pi FC. So this will be 1 over 2 pi times the frequency is 50 Hertz. So that's the frequency, 50 Hertz. The capacitance is 5 times this guy you see here is 10 to the power of minus 6. So when you calculate all of those, when you use a calculator for that, you should be getting around 636.36 ohms. So that's the XC. But that's not the impedance yet. So to get impedance is Z equals the square root of R squared plus XC squared. So that will be the square root of 53. So that's 53 squared plus 636.36 squared. So when you do that, you're going to get 638.6 ohms. So that will be the answer. And the answer is A. Question 38. In a constant volume gas thermometer, the needed temperature is obtained by change in dash. The volume is constant. The volume is constant. We're finding temperature. In that very gas, we're talking about a gas here. So let's look at gas laws. It's either you look at gas law or you look at Gay-Lussac's law. So when you look at the gas law here, since our volume is constant, what it's telling us is we'll then be having P1 or P and T. That is, say P and T are now the ones that are proportional. So P is proportional to T. Or you could even, some people call it pressure law. So P is proportional to T. So in this case, the answer to this very guy will become what? Will become D. That's what the answer will be. So you can observe the change in the pressure to find what the volume will be. So the answer is going to be D. Next one, the transfer of heat, which involves the diffusion of heat through matter from one end of the body to another without the relative motion of the molecules in the body, is conduction. That's the mode of transfer, because you're not shaking the body. The body is not shaking, you're not moving the body, but the molecules in it will be the one that are going to be moving. That's conduction. Convection is in fluids. Radiation in itself requires no medium to even start with. So that will be the answer. The answer is going to be conduction. And with this, we've come to the end of this very series. So we're going to see in the next series. It's still going to be released today. So make sure you hit the subscribe button, like the video, and share it across to everyone. Bye.